electron configuration, isotope formation, protons, neutrons, electrons. Don't forget to make a subscription.
Hey, Candy Busters! In this episode of chemistry class, you will be learning all about isotopes. As previously mentioned in our last video, neutrons are the only part of an atom in the nucleus that can be changed. This is because of isotopes. Isotopes are atoms of the same element with a different mass because of varying amounts of neutrons. The element chlorine exists as two isotopes, which are chlorine-35 and chlorine-37. Their overall mass changes. In chlorine-35, there are 17 protons. Likewise, in chlorine-37. In chlorine-37, there are 17 electrons, and there are also 17 electrons in chlorine-35. In order to calculate the neutron number of chlorine-35, subtract 17, which is the proton number, from 35. To calculate the amount of neutrons in chlorine-37, subtract the proton number 17 from 37. Therefore, the amount of neutrons in chlorine-37 is equal to 20, and the amount of neutrons in chlorine-35 is equal to 18. Here's an example question. Chlorine exists as two isotopes, chlorine-35 and chlorine-37. The average relative mass is not 36, but 35.45. In a sample of 100 chlorine, there are 77.5 atoms of chlorine-35 and 22.5 atoms of the isotope chlorine-37. In order to determine the relative atomic mass, we must first calculate the total mass. First, multiply 35 times 77.5. Add that to 37 times 22.5. This would equal the sum 3,545. This represents the total mass. The formula for relative atomic mass is total mass over the number of atoms. In this case, the total mass is 3,545 over 100 atoms. Therefore, the relative atomic mass of chlorine is in fact 35.45. We hope you learned a lot about isotopes today.
Bye, Candy Busters. Thanks for watching.